Hi everybody, and welcome to lesson number 13. Let's just jump right into it. Just a reminder about your projects. Ensure that you have got together, or at least started to plan with your partner as what your ideas will be and what you are thinking about, and then just let us know if you have any coding issues at the moment. If you can remember, last time we looked at the completion of Polygoner, basically the drawing program which could iterate through a whole lot of shapes and make a pattern with it. We then learnt about the logical operators and, or, and not. Remember that AND means true if both sides of the expression are true. So, did you brush your teeth and rinse your mouth out? If both of those were yes, your answer will be yes. If either one is no, then the answer is no or false. The OR operator is obviously just as you would say it. Did you brush your teeth or rinse your mouth out? If you answer yes to either of those questions, then the final answer will be yes or true. If you answered no or false to any one, if you answered false to all of them, only then is the answer false. And then we look at the NOT operator, which is basically to inverse a true and a false. So the example of that was, if you want to know all values greater than 10, you could also say, give me all values that are not less than 10. And that's quite useful sometimes when you don't have the right function to give you the one you want. You can use the NOT operator to give you the answer that you're looking for. Okay, today's mission, we're going to be looking at lists. We're going to create list items and populate them manually. We're going to then work with lists using code functions, and then we're going to go and jump into addressing Tera, but this time in a different way than what we did at our last session. Okay, just a quick update. We're going to start jumping around a bit now, so we can start cover topics initially as an introduction, and then we'll come back to them in later lessons. This is so that if you find that any of these functions will be helpful to you in your projects, we're going to expose them to you now, and then you can use them in your project. And if you want to learn how to do it something more advanced, we will be covering that a bit later. Okay, quick look at a list. So lists are basically an extended version of variables that you've already been using quite a bit up to now. The basic difference is a list allows you to store multiple items in a single, let's call variable or variable list. The example here would be a day list, and in the day list you can store the 7 days of the week. So a list is a grouping of any items which cover a common theme or idea. So a day list will be a list of day names, they're all the same thing. You could have a list of telephone numbers, a list of birthdays, a list of items you want to buy at the shops. So anytime a list where all items within that list share a common idea or theme. So as we said, looking at this one, we have 7 items on our list, the days Sunday through Saturday. If you want to create a list, you go to the data type palette, and you'll see there's the old make a variable, but below that is make a list. If you then click on it, you get the same options as variable for all sprites or the sprite only, and then you click OK. Once you've done that, you'll see a number of options now appear within that command block. You have the top, once again, the day list variable item with the tick box monitor on the left hand side of it. You can then use the add item to add an item to the list. It'll add a new item to the end of your list. We have delete. This has a number of options, but you can remove one or last or all of the items in your list using that command. Then you have the insert. This is different to the add in that you can here specify where you want the item to be added in the list. So if you want to insert it into position 3 in a list of 10 items, it will then push item number 3 down to position 4 and put your item in at position 3. Okay, so this is if you want to be adding things in a certain order and you want to keep them in that order, say alphabetical, you would insert items as you go along. Okay, we're looking at items replace. That's basically an update. So you can in place edit it. So if you want to correct somebody's name, spelling of a word in day list you spelled it wrong, you can replace Moonday with Monday by using the replace item. Okay, item 1 of day list is effectively how to access a specific item in a list. So if you want to know what item 3 is, what item number of day list is, whatever you're using it for. Okay, and we will cover the rest of the items in a later session. Okay, looking at the add function. So adding data to the list. So it's basically switch, bring on your monitor and you click on the checkbox. You'll see your day list item will now appear in your stage. You can now use a little plus sign to manually add entries, as you can see on the right hand side here. Clicking on that one, these blank items will be added every time you press the add button. You can use this little right bottom corner here. If you click on it and drag it, you can resize it. As you can see here, I made it wider to fit in all the names in the list. Okay, so that's basically how you add manual blank entries and how you expand or change the size. The length item here tells you how many items are currently in your list. Every time you click on it or when your program adds items, you'll see this number will increase by 1 when you use the add, and obviously decrease by 1 when you use the delete button. Okay, so here we can look at adding and removing items through code. If we have an item on the left hand side, we have the list of groceries, apple, orange, mango. If we now say delete 2 of grocery, item 2 orange will disappear. As you can see, you can use the 1. So we can replace 1 by any number or position in the list. Last was the last item added, so the bottom item in the list, and all will clean your whole list out. Okay, so here once again we removed item 2, which is the orange. If we now go and add lemon, remember add adds to the end of the list. So mango, because orange was moved up to number 2, lemon was added in at position 3, or the last one. Replacing and inserting items. So you can see here we have a list of phone numbers, and in this case we found that Kim's number had changed. So at the moment we've scrolled down slightly and we're sitting at number 3 in the list. So if we now go and say replace item 3, which is Kim, of our phone list with Kim and her new number, once you've saved that, you'll see that Kim's number would now have changed by whatever the change was. And we've gained a new friend, Mark, and we try and keep our list in alphabetical order. So Mark comes off between Kim and Paul, so that'll be position 4. Okay, so we want to bump position 4 down and insert something new at 4. We'll insert Mark at 4, and now you can see that Mark's in 4 and Paul's been pushed down to 5, and our length has increased by 1. Okay, accessing your list items. Here we have the item variable of day list. In this case, looking at our day list that we created earlier on, we can now go and say repeat 7. So starting at position 1, say item position of day list for 1 second, change position by 1. So what we're doing here is starting at 1, which was Sunday, it'll say item 1 of day list, which is Sunday, for a second. It'll then bump position by 1 to position 2. It'll then say item 2 of day list, which is Monday, and so forth through our 7 days of the week. Okay, you can go ahead and try this script now, and you can see what the result will be. Okay, trying to confuse lists. This is what happens when you're using the index or position of a list and you put in values which are not necessarily correct. So looking at the first item, item 8 of day list. Now we only have 7 items on our list, so if we went and asked for item 8, item 32 or 412, it would return an empty string, as there is no item in that position. Okay, the same thing happens if you enter 0 or -1, -2. Once again, these are not valid index positions, so it will return a blank string. The second one, if you enter 1.9, now the position can only be a whole number or integer value, so to get around this, Scratch will just drop the 0.9 and will refer to item 1. So if you went and put in 2.5 and once again drop the 0.5, and we'll just look at number 2. Okay, so don't use decimal values, use integer values here. If you insert an item in our day list at a position beyond the end, so beyond 7 in our case of day list, which only had 7 items, it will do nothing. Okay, you can't insert an item beyond the end of the list. So if in this case the highest value for this would have been 7. However, if you insert it at 8, okay, 8 is 1 beyond the end of the list, it'll treat this as an add function. So if you insert at the end of the list, it will just simply add it, which is the same as the add item. So only if you go beyond, so if you go to 9, 10, 11, 12, so more than 1 beyond the end of the list, will it be ignored. You can insert in 1 beyond the end of the list and it will treat it as an add. And then the same thing with delete way beyond the list. So in case delete 8 of their list, there was no 8th day of the week. So in this case it will once again just be ignored. Okay, let's look at a use of lists. We're going to now go and write a program called the random plotter. And these are our requirements. You're to ask the user to enter a number of random points that he wants to plot. So let's say I want to plot 5 random points. So the first thing you have to do is ask how many points do you want to plot. So the person can enter 5. You'll enter this value into a variable called items. You'll then loop in a program. Your program will then loop item number of times. So I said 5, I'll loop 5 times, and I will store 5 values as entered by the user into a list variable called myX. Then for each value that you've created in the myX list, the computer will pick a random Y value and capture that in the computer Y list. Okay, remember we're going to be plotting values here, so the values of X cannot be beyond, must be between minus 250 and plus 250 or thereabouts, and the Y values must be between minus 170 and plus 170. I can't remember exact values, but you can play around with that. But they must be within the limits of your stage. Okay. Once you've entered your item number or number of items, so 5 in our example, once you've finished capturing your 5 X points and the computer generated 5 Y points, you'll then draw a line joining in order each of those points. Okay, so this would be your requirements that we would give you. And how would they look in code? So the first thing we can do is create our variables. So on the left side here we have 2 variables that we require: items, storing how many points we're going to be getting, number, just to work our way through it, and we're going to have our 2 lists, computer Y and myX. So we want to go and create those first. Then you're going to create a function, custom function called setPoints. And as we said, you're going to ask how many points do you want to plot. And the person will enter number, let's say 5 for our example here. You will store that value in the items variable. You'll then repeat 5 times. If we use 5 as our entry number, you'll change number by 1. You'll ask join enter the X value for item number, so please enter the value for item number 1 to start off with. You'll then add that answer to your myX list. The computer will then pick a random number between minus 170 and 170 and store that in the computer Y. Okay, so this is first how are we going to enter or ask the questions and store our plot values. Once you've done that, you will then go and plot these values. So we define a function called plot points. You'll set number back to 1. You'll then go to the first item in myX and the first item in computer Y. You'll put your pen down, set your color to 0 just to initiate it, and then you'll repeat items minus 1, because remember it's minus 1 because we've already gone to the first one, so we only have to go through our remaining 4 points if we used 5 as our item example. Change number by 1, so we've now gone from 1 to 2. We're going to change our pen color. We're just dividing by items, just give us a gradient through the colors that we have as an option, and then we're going to go to that position, and in so doing draw a line between our first position and our second position, and then we're going to loop through, changing the color slightly, going to position number 3, and drawing a line from between points 2 and 3 and so forth. And if we just put this initialization code together quickly, let's clear the background, pen up, refresh, reset our number to 0, just clean our lists out, call our setPoints function, call our plotPoints function, and we could get a result like this. Now in this particular case, I just entered for our X values, I wanted 10 numbers, and I entered the values between minus about 200 and 200, stepping in 40 increments so that my x value kept going across and the y value, the computer jumped around, and this is the result we got. So that's just a way of using lists to be able to store plot points. If you want to store plot points in a program, you want to draw something, it's easier just to store them quickly in lists rather than manually storing them in go to commands. Okay, that's just an example of how you can use a list to plot whatever or draw anything that you want to draw. Okay, now we're going to step up to addressing Tera. Okay, in our end of our previous block we asked you to do this, and you'll remember that the address of Tera was made up of 1 Tera sprite and 7 costume sprites, each sprite being a different costume. The problem with that example was the only difference between all the costume sprites was really their, and I'll cover this what I mean again, but their offset positions. So you had the same code over and over again for 7 costumes, and the only difference between them was their plot or their offset positions. So we're going to change it this time. We're going to create 1 costume or 1 sprite with 7 costumes, and we're going to use lists to remember what each of the offsets was, and then when we draw them we can use 1 block of code and we just have to go and use the list to access their offsets. Okay, so just things to remember. This new one's the new version of Address of Tera is basically just 2 sprites, Tera and a clothing item. Your clothing items must appear on the right layer, so pretty much wings must be behind, t-shirt, blouse, a mask, and that must be in front of Tera, so we just need to make sure our layers are right. Clothing items have a fixed relative position to Tera, that's our offset. So basically when you click the wings it must go to a certain position relative to Tera, and that relative position is the difference between Tera's center and the center of the wings, and that difference between their 2 centers is our offset. And the clothing items must follow Tera if they have been clicked. So if I click on the wings and then drag Tera to another position, the wings must glide to her new location. Okay, so dressing up Tera, just a quick reminder of layers, which costumes are in front of Tera, basically all of them except the wings, and you can say the cape as well, but the cape is a little bit off her back, so it doesn't really go in front or behind her, it's actually next to her, so you don't have to worry too much about the cape. Okay, and which costume is behind Tera? We're going to use our layers function and our go to front commands to bring things to the front or to put them to the back. Dress up Tera, the relative position, just as a reminder again. So if we look at our wings, we have our center of our wing is there and our center of Tera is there. So when our wings fit correctly on Tera, they're going to be slightly off the center position. So there we can see is the center of the wings, there's dresser, the center of Tera. So if we had to say, okay, so where's the X relative position of the wings to Tera, we have to go and say, okay, so it's -5 gets us to the center of the X, the same X position of the wing. And if we look at the Y is 35 below or -35 below Tera. So remember, when you're going down it's negative and up is positive for Y, to the left for X is negative, to the right is positive. So if we need to move our center of the wings to the left of Tera center, then it's minus so many positions, and below minus so many Y positions. And then we're going to use the command glide to position of Tera -5, position of Tera -35 would be the static way of doing this, and the way we did it in our previous non-list version. We'll be replacing these 2 points with our list variables rather. And this is all the offsets as a reference. So if we're going to plot them all and put all the offsets in position, you'll see that these are the offset X and Y positions for all the different costumes. Okay. Now and then lastly we're going to use flag. Remember what flags were? We covered the using of variables as flags. So to remember when a item of clothing has been clicked on, we're going to use the clicked variable, set it to 0 initially, and when once you've clicked, insert to 1 so that we can remember when or if it has been clicked on. Okay, this will all become evidence in the code. We'll look at it a bit later. Okay, so when Tera moves, her X position and Y position will change. We will have to pick up whether it changed. Now Scratch doesn't have a nice event called MySprite moved. the way we have to work out if it's moved is we basically store her X and Y position. So when she does move, we then compare her current X and Y position to our stored X and Y positions, and if they're the same, she has moved. If they are different, then she has moved, and we can then handle that. And once we pick that event up, we then reset our variables, remembering X and Y position. We're going to be calling these variables old X and old Y. Set those to her new X and Y position, ready to pick up if she's moved again. And once she's moved, we're just going to broadcast a message to let everybody know that she has moved, and we can then handle it for all those that have been clicked so that they can come and find her again. Okay, this is top-down design. Remember the previous project, the polygoner was a bottom-up. The difference one again, in polygoner we started off with the idea of draw a shape and then draw that shape over and over again. We had no idea what the end picture would look like, end result, so we started off with the basic item from the bottom and we moved up to our end result. Top-down design is we know what the end result must be, we have specified what we want from you, so we know what the full project's going to be, so we need to break it down as we go along to make it simpler and simpler until we get to the bottom elements. Okay, so top-down design, we have two sprites with all the code. We'll break that code down under each sprite. The code for the clothing item in the sprites is the only difference is the initial positions and their offsets. The code can be broken down to 4 logical areas: the initialize part of the program, the when sprite clicked program, when I receive the moved command, in other words Tera is moved, and a go to Tera custom block which can be called from both the clicked and moved scripts. Okay, so basically looking at the initialization function. Okay, so when the green flag is clicked, put Tera at a certain position just to start off with. Then she must say, what should I wear? You reset her old X, or you set her old X and old Y position to her current position, so we can start tracking already if she's going to be moving at any point. And then in a loop, we just constantly compare her current X position to the one we've stored, and if, and here we're looking at the not, so if not X equals that, X position equals her stored X position, or not, so her Y position is no longer, not means not equal to, her old position, then set them and broadcast the fact that she's moved. So you can open up the library or the program Tera list, address of Tera list no code, and then you'll see in there already we have populated all your list variables for you, and we've created all your variables, so you don't have to worry about creating any variables and lists, and the lists are already pre-populated with offsets, so just focus on writing the script. So this is the initialization code. Okay, this is in the Tera sprite. Please work in your Tera sprite here. This is the only code, if I recall, that does go into Tera. All the other code will be going into the costume sprite. So as you can see there, we've done exactly as we said. We've set her position to her initial starting position. We've set her old X and old Y variables to her current X and Y position variables. We then ask, what should I wear for 2 seconds? And then in a loop, we constantly monitor whether she has moved. If she has, we then broadcast the moved message. Okay, now looking at our costume sprite. Okay, there is only one, and inside, if you go look at the costumes tab, you'll see all the clothing items are in there. Once again, we're just showing you all the offsets here. They are stored in the list, variables already. So when a green flag is clicked, set costume number to 0. We will now repeat for each costume, there's 7 of them. Increase our control ID number, costume number by 1, and create a clone. So basically here we're going to go and create 7 clones of our clothing items, so we can see all 7 items on the screen at one time, and each clone will be a different costume. That is what the costume number variable is controlling. Then when the clone starts, we're going to reset our click flag to 0. We're going to set the costume ID, which is a local variable, so this sprite only variable under the costume sprite, equal to the costume number variable that we are incrementing between 1 and 7. We're going to change our costume to that costume ID, and we're going to position that clone sprite to its own initial X, initial Y. These are lists as well. Okay. Third thing what we're doing is we'll then define the go-to block. We'll set the layer for that particular costume, and we'll glide to an offset position. Okay, so the offset position is the right position to attach itself to Tera. And then on the number 4, we're going to, when the sprite is clicked, we're going to then set our flag, click the variable flag to 1, and we're then going to go to Tera, call our go to Tera block. And finally, number 5, when I receive a Tera moved or moved message, if I click flag for that clone equals 1, we will once again call the go to Tera block. Okay, so looking quickly at the top down, we're going to write our go to Tera block. So define a custom block called go to Tera. We can then say if costume ID equals 6. Now costume ID equals 6 happens to be the ID for the wings costume. So we'll then say if it's the wings, go back 10 layers, making sure that the wings are right at the back. And otherwise we'll just bring them all to the front. Like I said before, they're pretty much all in front of Tera, so we can just use the go to front one. The only ones we have to worry about is the wings in this particular case. We'll then glide to, and here's the interesting one, X position of Tera. This is under the sensing palette. So if you go under the sensing palette, you'll find there's a blur of blur. So we want the X of Tera minus the offset position, okay, of costume ID. So whatever costume we clicked on, let's pretend it's wings. The costume ID of wings is 6. So item 6 of costume X. Costume X is our list, our X offset list for all our costumes, and Y, the Y position of Tera minus the costume wings, in this case 6, of its Y offset position. Okay, so if you go look at the costume X list variable and the costume Y list variable, you'll see all our offsets that we mentioned before are in there, and we're basically just saying go to the position minus the offset position minus the offset position. Okay, once you got that down, we'll now look. Now remember, this is under this the costume sprite as well as this. These are all under the costume sprite. Make sure you're in the right sprite when you're working with code. When the flag is clicked, we're going to reset our costume number to 0, and then we're going to go and create our 7 clones. So change costume number by 1, so set costume number to 1, and create clone of myself. When the clone is created, reset the clicked flag variable to 0, set the costume ID, so this is of this particular clone instance, to costume number. So for the first one, set costume ID to 1, switch costume to costume number 1, go to its original initial starting position X and its initial Y position. Okay, so basically place that item of clothing somewhere on the stage so they don't all cover each other up. Okay, so we've just given each one of them an initial starting X and Y position. Then when the sprite is clicked, we set our click flag to 1 and we call the go to Tera. When I receive moved, if I have been clicked before, then go to Tera. If I hadn't been clicked, I would skip over this code and not move. Okay, and that is pretty much the end of the dress up Tera using lists. Okay, you can go play with that code and see how it works. Okay, for homework, remember to work on your project. Remember to check out last week's lesson 12 and check out lesson 13, this lesson from Monday. Next lesson we'll be looking at string processing. Basically, remember that variables can store various different types of values, that being booleans, numerical numbers, and strings. And we're going to go look at what can you do with a string. So given a string, given the word hello, can we do anything with it? That's what will be coming next week. Okay, so do enjoy your scratching. Remember to work on your projects, guys. Don't leave it to the last minute, and we will catch you next week.